Uh, Hello everyone. Good afternoon. This is Swapnil here from Design Tech Marketing team. So I'll just welcome you all on the session. So today's session is Plant Designing Made Easier with Battery Solutions. We have our presenter, Mr. Kushal Pestod from Design Tech team, and Mr. Prem Kumar from Battery team. Hello Kushal sir. Hello Prem sir. Hi.
Hello.
Yeah. Yeah. So before handing
Hello.
over, yeah. Hello sir. So before handing over controls to Mr. Kushal, I'll just quickly take you through this tool particularly. So we are executing this webinar through a GoToWebinar tool. Just to update you, it won't be a one-way communication. So if you have any query, you can type your query in the chat window. I'm just dropping a hi message in the chat. Yeah. So with this, over to you, Mr. Kushal. So Kushal, so we can just
Yes.
take it ahead. Yeah.
Thank you. Thank you, Swapnil. And
Yeah.
hope you are able to hear me clearly.
Yes, sir. Clear.
Perfect. Perfect. So welcome back. Why I'm saying this is just except month of September, we were basically having a webinar series on different topics of plant solutions. And today we have an opportunity to get that from Mr. Prem Kumar. The main content he is going to present. He is a senior application engineer from Bentley and handling plant solutions for a very long now. So we will basically get chance to learn a lot from his experience. Anyways, before we get in today's presentation, I would just like to take you a couple of minutes on design text introduction, and then followed by that, I will do Bentley introduction for a couple of more minutes again. Okay, so thank you very much, first of all, for joining this webinar. Uh, so about design tech, we have three major business verticals. One is technology partners for leading CAD/CAM PLM solutions and additive manufacturing technology, which essentially is a 3D printing technology. Second vertical, business vertical, is engineering services, which basically caters services in the area of design and development activities for various domains like aerospace, automotive, heavy industry, defense, and so on. And that is where maximum number of engineers are housed, around 850 engineers across country. Third business vertical essentially like complements both this first one in order to create a skilled manpower, or maybe we also call Design Tech CAD Academy as a finishing school, which trains engineers and hone their skills and make them ready for an industry for a various CAD CAM CAE solutions. About business alliance, that technology partners that I was talking about, we have a leading CAD CAM CAE development companies with us. PTC essentially is a well-known in the area of CAD and PLM. Altair essentially addresses most of the simulation requirement, whether it is structural, thermal, CFD, and some other areas also, like electronics, communication. Stratasys and Solidscapes are 3D printing technologies. I mean, these are the machines which we basically provide, and lot many other brands also. Today's topic is basically belonging to Bentley, which is encircled here. About Bentley, we are anyway going to talk little more, so I will not explain it to you here itself. And then these are various communication channels by which you can basically communicate with us. Common email ID info@designtechsys.com. There are two websites. Designtechproducts.com basically talks only about the products that we are dealing in. Products, when I say, it's all technology products like CAD, CAM, PLM, BIM, and so on. LinkedIn, Twitter, Facebook, YouTube are some of the social media channels you can basically remain in touch with us. YouTube, you will be able to see a lot of customer case studies in which customer themselves published some of the case studies where they have made use of our technologies that we have implemented over there. So that's about design tech. uh, before I hand it over to Mr. Prem Kumar, I will again take a couple of minutes and talk to you about Bentley. So Mr. Prem Kumar is going to be presenter for today's topic about Bentley. Bentley is global leader in various domains which are like listed here: structural analysis, construction simulation, road and rail, infrastructure asset operations in terms of managing the complete asset, process plant operations, collaboration service, and now leading in offshore and marine solutions also. Uh, in fact, we are recognized as I mean in uh, infrastructure 500 top owners. Uh, the top 50 international ENR design firms use Bentley software. So that speaks about what Bentley is. Our mission, innovative software and services, in order to provide innovative software and services for the enterprises and professionals like you who design, build, and operate the world's infrastructure, sustaining the global economy and environment for improved quality of life. That's the mission statement. The slide that you see in front of you is also called Bentley City or a model city, uh, which you can where you can see multiple types of infrastructure, almost all which we make use of them in, and we see them in surrounding, right from roads and bridges, rails, offshore structures, um, power plant, nuclear power plant, water and wastewater treatment plants, and so on. You can as well see rail and transit also. So you name any infrastructures which are basically shown in this model city. Why am I showing this? Is to talk about how Bentley addresses all of these infrastructure type that we see. So now you can see beneath the name of the infrastructure, you can see list of applications that we basic that engineers apply in order to realize those infrastructures. So this is basically a we can say application playbook of Bentley. For example, if it is power plant, in order to realize that, we have open plan and auto plan, which is 3D design tools. I mean, right from 2D to 3D, all different modules it has. Autopipe basically is a brand which addresses pipe stress analysis and vessel design. Promise will be utilized by electrical engineers. STAD anyway you all know, which is very well known structural tool. And likewise there are many other applications which people can basically make use of, which will be utilized by obviously different discipline people, multidisciplinary people, because power plant is, I mean, any infrastructure for that matter is multidiscipline only. So while we say they are all multidisciplinary infrastructure or applications, there there is need of collaboration, data management, tracking the changes and tracking the whole project development. That is where project wise comes in picture. Now asset wise is largest application, that is, we can say, largest umbrella of application, which basically takes care of asset life cycle information management, um, asset reliability, operational analysis, maintenance of the asset, and complete like life cycle of asset will be taken care by asset wise. Now to in order to work on a different technologies, GUI, the backbone of all those GUI application is MicroStation, which is common CAD engine behind them. So it makes engineers job easy, from learning one application to another application, they don't take much of a time because the environment remains same. So microstation is backbone of all the geo application that we have. And that is it about Bentley systems. Now I will hand it over to Mr. Prem Kumar for taking you through today's presentation. So over to you, Prem.
Thank you, Kushal. Can you make me as a presenter?
Yes, yes.
Done, sir. Yep.
Yes.
So you are able to see my screen?
Yes,
Yes,
we're
sir.
able to see
Yes.
your screen. Yeah.
So, so you are able to see my PPT slide, right?
Yes, yes, yes.
Uh, Hi, very good evening to everyone. Vishal has given a detailed introduction about me. So, I being a senior application engineer, so I was in Bentley for almost more than 8+ years. So today we are going to see about the open plant. This is my detailed agenda. So we are going to see about advancing infrastructure provided by Bentley, then what is a open plant design solution. So we have came up with a new concept, which is a voice command inside the open plant solution for easy creation of PNDD as well as the 3D layout, and will reuse the information which is created in the PNDD level inside the 3D layout. Then we'll see about the extraction of project deliverables, which is the key factor for in our project. Then we'll discuss few success stories about the open plant presented in India. Then Q&A followed by summary. So this is our agenda. So I will be sticking very much on this agenda, not to bore or get deviation apart from that. I hope right now you are able to see the project digital twin with the BIM vertical, right?
Yes, yes, Prem.
Right. So we know that nowadays many of them are talking about digital twin, right, in the plant industry or manufacturing industry. So any asset based or any manufacturing industry nowadays the government made everyone to be aligned with the digital twin. So in our plant, BIM verticals help us to achieve the digital twin um, over for assets. And we know that BIM is a process to create a correct, consistent, and complete asset data in this project digital twin. So here, right bottom corner, what you see are the different dimensions, which are 3D, 4D, 5D, 6D, and 7D for facility management. So these are the different dimensions which are part of different life cycle of the plant, right, which starts from concept to ends with operation and maintenance. Whatever we create over in in concept as well as detail engineering, those information will help us to get in the right track of all those dimensions. So basically, people, whatever the data or model they create, they used to say it's a BIM model, but it's not a BIM model. Again, BIM is a process to create a asset information model. So basically we are creating the models with all the asset informations to help uh, to help the owner operators for better operation and maintenance. This asset information model is a terminology derived by the global leaders, including the Singapore government, who extensively aligned with this BIM process. So here, Bentley advancing infrastructure, which provides a complete solution. So from a simulation to the decommissioning, which start where it take a lead on conceptual design, detail design, then construction, operation, and decommissioning. So at center, what you see the green circle, which has the name of the platform technology. So there is a platform open plan, which is used at design engineering level for engineering activities, and project wise is an engineering document and data management system. Asset wise is a asset management system. So these three will plays a key role on this asset life cycle to be safer and greater in achievement of project digital. So here these are our partial user list, where Jacobs, Hatch, Black and Veatch, Worley Parsons, CGC, Indian Oil, Asenco, who are all use our technology extensively for their projects uh, across the globe. And now we will get into the open plant environment. So open plant is being used in different industry like petrochemical, chemicals and special chemicals like pharmaceuticals, then energy as well as the power, minings and metals, then utility system like water and wastewater management systems. So in general, any platform technology will mostly adhere to the greenfield project. So open plant supports the greenfield project, which are majorly happening in China, Middle East, India, not only across the globe. And the other advantage of open plant is it also supports the brownfield projects, where you can execute the minor changes in your existing facilities. You can use the point cloud data directly inside the open plant without any add-on applications. Here we go. Now we'll see in detail about what is an open plant. Open plant is a multidisciplinary solution or software which will help you out to do piping, equipment, HVAC, as well as the electrical components. We introduced the voice command to make the engineers or modeler. Hello, is I'm audible?
Yes, yes, Prem.
Okay. So, where voice command is become a user friendly for the engineers, and open plant which provides the complete, consistent and correct data throughout the plant life cycle. It has different modules like P&AD for process creation or P&AD creation, then modular for 3D physical design, isometric for isometric drawing, extraction and management, orthographic manager for GA extractions as well as section views, support engineering and data management solution. Over here, when we talk about the P&AD, we understood that P&AD is not a single person input or creation of a whole idea of a single person. It's multiple stakeholder who are involved on creation, as well as the process engineers, reviewers, sometimes the suppliers as well as the manufacturers who gives the data about the assets, right? So the final P&AD is the collaboration of all these persons. We understand this environment, and we have came up with the solution to take this in a right path and help the owner operators as well as the engineers to be process design very good and make easier. The key advantage of open plant P&AD is which is developed on open data model format, which is an ISO 15926 for data format. It is a spec driven application. It has its own CAD engine. It doesn't need any add-on CAD engines, and it can recognize your voice to fire up the commands. And it has inbuilt libraries, symbols, then reports. You can also embed the supportive documents like um, like a layout, any PDF documents, Word documents, and so on, for the review purpose, internal review, or for operation teams. And it's a rule-based system. It can it can work, or it can accept two file formats, which is DWG and DGen file formats. So you doesn't need of separate application to generate the DWG files, where OpenPlant is capable to handle those DWG and produce the DWG P&AD drawings. So now coming to the voice command, which we introduced newly inside the OpenPlant, there are few case studies. So example, Stanford University done a case study, and they found that voice command which makes or works 3 times faster than typing. So basically we use the tools, or we will go and search the tools, or we'll type the commands. Instead of that, use the voice command, so that you will be 3 times faster than typing. And the Google DeepMind also achieved with some case study scenarios that they proved that 6 times voice command is better performance than the human experts. So we'll see this in live, how this voice command helps in P&AD creation with all the informations. Is everyone able to see my screen?
Yes, Prem.
Yeah. So right now, what you see is the interface of OpenPlant P&AD. It has the ribbon tools like equipment, piping, instruments. This ribbons has multiple again tools for the placement of components. All are intelligent components. Here the ribbons is being decorated, or it has been managed as per our P&AD workflow creation. At bottom where you have the component gallery, it has all the symbols. As you switch on to the different domain or different activity, the respective tools will be loaded automatically at the component gallery. And in standard preference, where you can set the preference like specification and conditions, as well as the WBS element, where you can set over here in this environment. And engineers can create their own WBS element, and it is completely configurable and customizable one. And this is one of the existing P&AD, where you are able to see the process lines, components like valves. Uh, as I said, the components, whatever is presented over here, is not the dumb graphics. It's all our intelligent data, where you can see the design conditions, tag number, size of the valve, as well as the rating, specifications. These are related to the tag informations, and you can see the material, manufacturers, and so on. All this data is being read from the specifications, which is at the back end. And here you can see the heat exchangers by the tag information and the design conditions and so on. You can customize this presentation or viewing format according to your project standards and needs. And again, the process line, whatever you see, it has all the process information, or it's an intelligent component like sizes, specs used, tag, and from to data, etc. So now in this P&AD, we'll make a small changes over here. This is the area where we will work at this moment. We'll add a pump as well as some process lines, including the valves and so on. You can also have the assemblies. You can create the assemblies. You can insert the assemblies, and these assemblies can be configurable for any project. If you create assembly for project A, that can be used in project B, and so on. Those can be organized at the organization level. So now we are going to play around with the voice command, how it is easier to operate the P&AD, or create the P&AD drawing. It doesn't matter what kind of technology you are currently using in your organization, but the voice command will help you out. I mean, the open plant PNDD will help you out to incorporate those voice commands directly inside the open plant, and you can go ahead. So now let me load the voice commands inside my PNDD application. So right now what you see is the interface of my voice command console. Here where I have the start and stop button, and this is my accuracy level. Here where I can set some, some slot or accuracy or sleep mode and so on. Here I have the function or interface to incorporate my own commands. So here you can see my commands and the response given by the computer, and the commands are fire up at the time of doing the creation of PLAD. So example, I have just included three of the Autodesk command like zoom, extend, zoom in, zoom out. So like that, you can use your own words, domain words, to place the objects inside it. So now let me start up this and take a lead on this. Place pump, place pipe run, place check valve, place gate valve, place gate valve. So now I have just used my voice to place the pump as well as the process lines and the valves. So if you look at this, the direction of the check valve, not only the check valve, the direction of the valves completely based on the direction of the pipeline what I have drawn. So here the system is intelligent, as I said early. So the sizes, direction of the valves, all the process information will be taken from the process line. So here you can see that this pipeline is being started from this existing pipeline and ends to the pump. But the scenario is we want to reverse the direction according to my process data. So when I do the changes, automatically my check valve direction is being changed. So now the process line is started from my pump and ends to this main line. So this is how the rules are derived at the backend directly. So again, now I will start up my voice command for placing some other components. Place concentric reducer, place PT, annotate line number. So now I have just completed placement of the components directly over here by using my own industry language or terminology or industry words to place the component instead of browsing and searching the command or typing over on the keyboard. So this is how the industry says that we are, when we use the voice command, we are 6 times faster than typing it. So now it's all about extracting the deliverables and so on. So let me show you reports. So these are report for pipeline. These are report for pipeline where you can easily customize it. So where you can see the line number, including the size, unit, service and specifications. All these reports can be exported to different format like PDF, Excel, CV, as well as image and so on. And this template can be easily customizable as per your project needed. So here you can extract the hand valve reports, instrument reports, control valves, and so on. So this is which are belong to the hand valve reports, where you can find our newly placed valve HV002 check valve, as well as our new gate valve which we have placed over here. So the reports you can extract like nozzle list, equipment list, then control valve, all instruments, as well as valves, process lines, and so on. Apart from that, even all the instrument components can be fired up using the voice command. Place capillary tube, place electric, place hydraulic, place mechanical, place pneumatic, place analog. So as I said, you can place all the instruments. You can create your loops. All the lines can be directly accessed over here, and you can see that if you place any component, the system won't allow you to have a orphan data in your orphan data in your drawing. So it will definitely allow you, or it will definitely push you to define the tag for those components, which confirms that it won't allow you to have the orphan data in your intelligent PNDD. So uh, now let me show you the another interesting one. So for even for our internal purpose or for external owner operator submissions, even you can attach the supportive documents to the component. Say example, add add documents. See, now you can see that I have added a PDF document to this pump. Whenever if I want to open up the document or remove the document, this can be easily done. You can see the remove link, edit the link, and so on. And if I want to open up the document directly from the PNDD, yes, as a draftsman, they can open up the document, the PDF document, whatever we have given, and you can attach the PDF document over here. Not only the PDF, you can even attach the any files like DGN, DWG, shape files, Word file, Excel file, and so on, whatever you get from your own operators over there. And you can have the functions to switch on and off over here on this PDF symbols. And again, you can directly submit, or you can push this document for internal review purpose, as like go for here where you can publish the model for the review purpose. Here we go. Here, OpenPlant has an technology called Bentley View, which is a free version where user can download and view the PNAD drawing, as well as they can view the 3D as well as the 2D documents over here, and they can see all the informations presented in the PNDD drawing. So here, this is a review application where you can see the Bentley view. It's a free one. Again, if you are reviewing the 3D, you can use all these measurement tools to review it, and you can also use the voice console over here, and you can see that the pump, whenever I select the pump and look at the properties, you can see the information like file link is being added as well as the items. You can see the data about the pump as well as other process informations over here. So any data presented in this review file, which is in the format of i.dgn, can be viewed inside the Bentley view. And Bentley view also supports the different file formats like dgn, dwg. So these are different file formats which can be used in this Bentley review application, like Triforma, dwg, dgn, then cell files, obj, mesh models, and other file format like ifc and so on. So now we have created the PNDD drawing with small modifications like adding the pump valves, as well as the gauges. Now we will input this data, or we will use this data directly in the open plant modular. The engineers can directly use the delete functions, so that the delete will be this component will be deleted from the uh, graphics level as well as the database, which will done automatically. Doesn't need to purge every time in the real-time scenario. So this is all about the PNDD interface as well as the solution, how the voice command is being used inside the PNDD for quicker drafting. So now let me switch back to my PPT over here. I think everyone is able to understand. I'm a little bit slow, right, Kushal?
Perfectly
Okay.
all right, Prem.
Okay. So now we have
Yeah.
seen about the open plant PNDD. As a next step, I will get into the 3D modular environment. So again, it's a application which is developed based on ISO 15926 standard. So ISO 15926 standard stands for storing the data format at the open level. So if you create data, it can be reused by any application without any separate programs. So that's how plant industry is compliant to store the data in 15926 standard. And it's a multidisciplinary application, spec driven, scalable, which suits for small scale project to large scale project. Again, the voice command is available for 3D modeling also. And you can integrate the process data between the PNDD and the 3D model environment. As I said, Open Plant Modular can directly uh, use the point cloud data, I mean the laser scanned data inside the Open Plant Modular for brownfield projects. And if you are user of PDS, yes, you can bring the PDS model inside the Open Plant with all the intelligent. And again, for small minor expansions or changes where you can execute it. Moreover, we are delivering the application along with the SDK, where the engineers can customize the software according to their need. Example, if they need something special equipments, they can create by them own as a parametric equipment. We are open to allow the user to do all the customizations. So finally, where you can extract the reports, I mean the bill of material, clash detection, then piping fabrication drawing, isometric drawings, including the spool diagrams, then GAs, and what you get is LOD 400 by default. If you need 450 and so on, yes, you can customize by editing the schema, and you can achieve the top level data set informations can be integrated inside the open plant model. So now we'll see about how the open plant modular can take the PNAD data and how the voice command help us to do that. So currently what you see is one of the model of model where you can see the graphics, how strong it was, and you can do zoom in, zoom out. Even the graphic sizes, let it be any size, doesn't matter in the Bentley environment. Everyone knows that Bentley is mainly focused on these graphics as well as all the data to be handled or any kind of project size. So now coming to this environment over here. So these all are ribbon tools where it is presented as like P&AD. You have piping equipment, HVAC, raceways, and so on. When you select the equipment, the respective components which are related to the equipment will be presented in the component gallery, and the piping tools all are presented over here, and so on. So now coming to the in general, people used to ask how to reuse the other third party data, whether we can import inside the application and convert as an intelligent component. Yes, you have the facility to do this, where you have the user defined component, you have solids, you have the in-house, I mean the inbuilt 3D tools to create the component, and also you can import the models from different file formats inside the open plant to have an intelligent or convert intelligent component. So example, it supports DWG, DGN, and at bottom where you can go for different exchange file formats like FBX, GT file format, IGS, IFC, step file, and as well as the XML and DXF. And getting into the 3D modeling types, so SAT file, ACAS, then SketchUp, 3DM, Parasolid, dot underscore T, as well as Y, and OBJ file formats. These are different file formats where you can import inside the OpenPlant modular and convert as an intelligent documents. And coming to the again reuse of data, here we go. So whatever the data I have created in the P&AD can be seen over here, which will be listed with a color code. So here you can see that pump PMP3102, which we created in the P&AD, is presented red in color, which means that confirms that presented in P&AD but not in 3D environment. And again, when you expand the pipeline, you are able to see the pipeline 003, but in our case, it's an pipeline which is a P-02, where we have the two operator, I mean the valves like gate valve and the check valve. So now we'll take a look how to reuse the data directly over here from the P&AD, as well as as well as using the voice command. Let me load the voice command over here. So let me change my accuracy over here and go ahead. As I shown early in the P&AD, we also have the list of commands where you can use over here. You can see here I have just incorporated the few AutoCAD commands like a pan, up, down, zoom, extend, zoom in, and so on. Like this, you can create your own commands over here. Even instead of pan, you can say move top, move down, and so on. So this is completely a configurable one, and the system will give the response what you need exactly. So now let me close this and fire up the voice command. Activate horizontal pump. Place PMP3102. Show isometric view, pan up, open nozzle manager, activate pipe. Hello, activate pipe, acute top, join pipes, place gate valve, place check valve. Hello, place check valve, modify valve, see now I have just used my voice command for the placements of all these pump, pipe, changing the compass over different direction. Then I have just fired up the command like join pipes. Then I have had a different browser to do the pipe connections. What are the commands I have used? All are layman terminology, where you can see the pump which is being changed from red color to green in color. And again, if you browse over here, the for the gate valve, where you'll be find green in color. See pump valve tag number HV006, which confirms, all this confirms that we are reusing the PNDD data in the 3D modeler environment by using the voice commands and browsing all the informations. And going ahead, on top of this, you have the pipeline manager, which will allow you to see all the informations about the component or pipelines which are presented in your model. So these are the pipelines which are presented in your model, where you can filter or search the data accordingly over here. So now the engineers have facility to do the highlight. As you see here, now the component or the pipeline, the respective pipeline is being highlighted, and you can isolate the component. Apart from that, the general commands like changing the file size, I mean the pipe size, moving the pipeline from one line number to another line number, all those spec changes can be easily done over here. And you also have the validate spec for component. So this is something unique one. So example, you are executing the project simultaneously, there is some changes in the spec. At the time of modeling, you can do the cross check between the your piping component versus the newly created spec. So automatically the system will give the list of variations, and the engineers work is to accept it and go ahead according to the spec revisions. So these all are inbuilt over here. And at top where you can export all this pipeline data to different environment. Let's say you can generate spool IDs, you can export data to stress analysis, you can do the consistency checks over here, as you see here, and so on. Now coming to the reports, yes, um, activate report dialog. So here you have the report templates where you can use to generate the bill of material based on the line number, or based on the area and so on. So these all are completely different report templates where you can use, and this can be completely a customizable one. What you see is the bill of material based on the line number, as you see here. And as I said early, it can be completely customizable or configurable one. You can export this report to different formats. Right now we are seeing the line number, the same. We can have the val list, the control val list over here. Then you can have the complete val list reports, pipeline list, then HVAC, equipment list, nozzle list, etc. So now as a part of the part of the modeling, where we want to extract the deliverable like isometrics. Yes, isometric manager, which will allow you to generate the isometrics here. This is the line number where we have to generate it. Once you have created the model, you can process it. You can see here the time frame which is showing to generate the isometric drawings over here. And this when you expand this tree, you are able to see all the components which is presented inside the respective line numbers. And the key important is, whatever the isometric drawing you generate here is not the dumb graphics. It's all our intelligent isometric drawings. So let me open up one of the isometrics over here. So you can see the bill of material in the right hand side. This is completely, this report format or bill of material format can be customizable one. All the CAD standards can be implemented, where you can change the title blocks. So you can see here sheet 3 of 3 date, and the drawing number which has the line number over here. And you can see the dimensions which are generally happening in all the technologies. The unique functions of the isometric manager is you can see the information about the component directly over here. Example, when you select the valve, so it will give all the information, what kind of end conditions it was, what is the spec used, what is the long description, what is the operator type, who has created, what is the material manufacturer, what are the data presented in the spec will be reflecting over here. So no need to again switch back to the 3D model to see the information. Directly you can see all the information in the isometric, and you can consider whether it is approved isometric or unapproved, sent back to the designer for the changes, where you can see the name, tag, then line number, and so on, description, etc. Say the other unique function of this isometric is, so we can see that the um, what the tag number which is being placed over here for the operator. I can just move this label easily. So the open plant is the only application has this function at this moment over here. So without breaking the relationship, you can just play around with these functions over here. As you see now, right? You can see this big break what it was presented. So this kind of modification can be easily done. The difference between the other technology and here is whenever the isometric is generated, it will be presented as a cell, and it doesn't have relationship with the tags or annotations with the component. But in open plant, you have the relationship. You can move or stretch these annotations according to your need, and you can see the component informations directly over here. So then the other deliverable, or one of the key in our 3D modeling environment uh, is clash detection. Kushal, is I'm audible to everyone?
Yes,
Hello.
you are audible.
Okay. So is there any doubt we want to take Q&A now or later on? Any questions?
Uh, we have, can we track the BOM changes between revisions? That is the question asked by Mr. Karthikeyan. As you wish. I mean, if you want to answer them now, we can answer
Okay.
them. Otherwise, we have a Q&A separate towards the end
Okay.
of the session.
Okay. So we'll go ahead on this at this moment.
Correct.
Okay.
Okay. Okay.
So then we'll take the Q&A separately. So moving ahead over here, there is an inbuilt function for clash detections. So here we go. You have the clash detection interface where you can create a job. Job is nothing but assigning a definition for clash detections inside the technology that how piping example in this case piping versus the equipment. The clash detections can be performed based on different scenarios. One is based on the levels, as you see now. As I push the component, you can see the color code is being assigned over here in the graphical area. The other one is completely like based on the files or based on the named groups. So in our scenario, we are doing with an example of levels just to process it. And here you have the list of rules. The user also have flexibility to create a new rule and execute the clash directions. So now let me start fire up the process. So when you start process it, you are presented with the list of clashes over here. As you see now, so right now, what you see is the list of clashes. Uh, Overall, around 48 clashes. So here, these all are hard type clashes, and you can see the element data like element B and A. So whenever I select this, so here you can see the color code which is been assigned to the component. So here we are getting the clash between the pipe versus the I mean the round circular staircase where there is no clearance uh, is being provided. So that's how we are the clash is been reflecting over here. And so here I feel or I observe that this is completely belongs to all these clashes are belong to same line number over here. The engineers can also toggle it toggle it just by over here. They can keep on switch off the components as you see now for better visualization at this moment. Okay. And the another advantage of clashes inside the open plant is, so now we have derived the hard clash. So we'll go ahead now, we'll set some more soft clash. over here and start the process. So now I'm running the clashes along with the previous one, I mean, which was early performed. Here you can see the status about the clash report, which gives the new, as well as I move down, you can see the old clashes also, which gives the status completely. The new clashes all are, you know, some mostly like an clearance, and here you have the locations over here, and you can sort the component over here. Let's say example, let me go for sorting at this moment. So here you can see there is a clash between, I mean, soft clash between the well neck flanges, pipes, and other equipments, etc. Right. So gaskets, hand wheel. Let me take this hand wheel, and it's an clearance check. Let me select this. So automatically you can see that there is an operator, as well as some support was there. Let me isolate the object over here, and you can rotate it wherever, however you want to have better visualization. So here the thing is the operator doesn't have the clearance, 50 clearance with this support steel. So this is one scenario. So like this, you can perform the soft clashes between the different domains. And the other beauty of the clash over here was, I can create a new groups over here, and I can push the components or clash reports based on my based on my status. So right now I have selected all this. I'm just pushing these clashes over here. Say now I am pushing all my old clashes to the group one, so that I am aware that group one contains all the old clashes, and the others all are new clashes, where I can track all those changes, whatever happens over the results. So it is easy for the engineers to do the multidisciplinary clash detections and so on in the project. So now when I open the group one, I'm able to see all the old clashes. So I can give the even I can rename this as an clearance clearance to be provided, so that we are sure that the engineer will take care of this scenario, and he has the track what are the clashes he has under this group. So like that, you can create a new group, and you can keep on push all this according to your need, and further you can do the clash detection in your project to make that your model is clash free, clash free plant at the time of design, as well as the clash at the time of design, as well as avoiding the critical scenario at the time of construction. And these results can be exported to different formats. One is Excel or CSV, as well as the other format is GPS coordinate system. If you are enabled the geo coordinate system, I mean in this CAD environment, automatically the GPS locations will be extracted, and it will be shared to the other team member, where they can import those points in the other technology, and they can do the respective actions on their native application. Kushal, can you take a lead further to show the orthographic manager?
Yes, yes. Thank you.
Yeah.
So let me share my screen now. Okay, Prem, just help me uh, telling whether you are able to see my screen.
Yes, I am able to see
Okay,
the screen.
okay. So orthographic manager is an important module in open plant sort of solution, which basically generates the GA drawings, orthographic drawings of plant or area, the way you basically want your GA drawings in. Okay, spend less time drawing and more time designing is a tagline used for orthographic manager. You will get to know why we basically use this tagline. So what is open plant orthographic manager? In couple of lines, if you basically want to put it in this way: tool that enables user to generate faster and high quality GA drawings. GA drawing is really very important, and their quality is equally important for plant erectors and engineers who are basically on site to realize the design that we have actually done on computer. It creates a 2D orthographic drawing from 3D. Obviously, this is the ultimate aim. Why do we basically create 3D? Uh, and before we generate orthographic drawing, GA drawing, which has no clashes, which has no problems, uh, then only we go and create GA drawings. So with complete high quality annotation, label placement, now because you handle large amount of data in terms of number of pipelines that you have in your area or plant unit, number of pipes, equipments and instruments that you have would be large in number. So majority of the time people will have their own standards to follow things in a particular way. So for example, certain service will be shown in one particular color, another service will be shown in a different color, equipment's color would be different, representation of pipe, whether you want to show a parallel line or a single line, all sort of things you can have a complete clarity on, or you can basically atomize that as well. We will see that further. It allows user to generate single line, double line. We have already spoken about nominal setting. That can be made as a setting, and then you get drawings very quickly. Okay, so open plan orthographic manager, couple of highlights. It increases productivity with drawing automation, rapid drawing management through multiple views. You can create as many views as you want, which can give complete clarity to erection or a site engineers about the plant. Increase legibility on deliverables. The deliverables that you basically give should be legible enough for them to understand very clearly. So how does it creates improves productivity? Is because you don't have to put manual efforts, laborious in terms of putting the labels there, changing the color layer by layers, putting them in a different layers, uh, like how we basically generally do in 2D softwares like AutoCAD. Here majority of such things can be automated. So open plan orthographic manager automates the production of drawing and increase productivity, allowing designers to spend less time extracting 2D files. Output of orthographics will be with annotation applied for various disciplines. It can be useful for your procurement team, or maybe a site engineers or erection team, cost estimation team, whatever. The purpose could be, that each and everything that you put in drawing, it serves the purpose for a different team that are basically there to realize the project. Rapid drawing management through multiple views. As I said, to realize any projects, you will have multiple views. And how do we manage them when you take that? So like any of the applications that we see in under open plant has a very good methodology of workspace and work sites. So that continues even for orthographic manager also. Open Plan Orthographic Manager allows users to automatically create single, double line drawing output how the way you want, all those through a simple configuration setting, enabling line display to be controlled through pipe size. Depending on the size of the pipe, also you can uh, maybe some of the lines should be thick, thin, based on the pipe size. You will be able to actually differentiate. So let me show you software, how it works. Pretty much simple, but very important module in the whole process of generating GA drawings. So like I said, it has workspace and workspace. Okay, uh, you can have multiple workspaces depending on the project that you're working on. So what you see here is the list of an existing views that engineers have basically created. So if you see on the left ribbon, blue ribbon, you can see setting, title block. You can have your own title block, in which things will be automatically updated, who has created, and scales and title and so on, right? Then view definition obviously is one of the important thing, and then finally drawing generation, and you can extract report also. Very step-by-step, things. Setting is one of the most important thing on the top, which drives all your output generation down the line. So here let's see how can we quickly create view. So create view, I can name the view the way I want. I mean, here we're just putting demo 1 view. Otherwise you can have your own names of the view, like unit 1 view, unit 2 view, or something like that. Okay, the file that I'm going to refer for generating this demo 1 view, okay, I can select them. Let's say, let me select a couple of them. Okay, open. So that has been referenced model. Then now every file must be having their own views, isn't it? So what view you want to consider as a demo 1 view? Top view of that particular file, or you can load it in 3D and mention that this is what my demo 1 view is. It may not be, the way you say this is top view, that is top view, because 3D model basically is the space. Okay, this is how it is basically previewing it, without, obviously without dimensions and all, because we have not yet generated the drawing. Okay, so you previewed it, and if it is acceptable, you can go ahead and generate drawing. Now where do you want to position that view that you have created? From in the seat, title block. So that is what it is basically talking about, positioning it. Okay, you can in fact clip the area. I mean, one particular area GA drawing you want to create for, because sometimes what happens, if it is large plant or large unit, you may not be in a position to accommodate them in single seat. So because of which you generally clip rest of the things and put it in that particular view. So all those settings you can do, and uh, go in the next steps to generate a drawing. Obviously scale and all is very important. Okay, so next let's go to the step next and generate. So you can obviously generate all the views that you have already created and generate drawing for. That's the reason it is manager, orthographic manager. So you can basically manage them without spending time. You generate view and then process it. You can get hundreds of drawings processed in orthographic manager. But here we are just for a demo purpose, only one view we are basically processing. So let me generate a drawing for that particular view. I will go back to the, yeah, now you can see the drawing which was just previewed earlier. Now you can see dimensions, from the reference line that you have, grid lines where they are placed. Okay, so that the layout, people will understand where particular equipment is placed and how they are running, right? You can see dimensions and lot of other annotations, to make them clear. Obviously, you also get nozzle list and their nomenclature as to which is N1, N2 of that particular equipment. And then similarly, you get list of the valve and what is the type of valve it is. All those you get. Obviously, here if you basically map the data, you can in fact automate that as well. Scale and all, it can automatically bring in over here in the title box. Now, as I said, you can define your own attribute, style, and all. So let me just show you how we can basically change the setting. Obviously, about border, about dimensions, about annotation, all different settings you can actually make depending on need of your project. Okay, so let me go to label and show you. These are the different labels that are basically shown. Pipes are placed in one layer. Then again, you have multiple pipes, isn't it? So every pipeline you can have a different color. I mean, if you want. Okay, so how the pipe center line should be shown, other components like how equipments to be shown and all. Let's say equipment, I just want to change the color to, let's say, blue. Okay, and let's see if it updates that. Just save. Let's regenerate the drawing again, up, which will have newer settings. Clear the file which was created earlier because that was not final. It was intermediate one. It shouldn't unnecessarily occupy the space of my computer. Right? So much of details, it has basically taken care of. And let's go back to the graphics and see, how the new settings are being applied. See, the equipment that you see, tank and pump, both the pumps you can see blue. Yeah, heat exchanger color, uh, other tank, all equipments are seen in blue. So that is how you can actually play with the various other things. It is annotations and all of the things. Report, which is another important thing. I mean, uh, your procurement team sometime don't require drawing, but they need list of the valves, list of all instruments that you are using in that particular unit. uh, you can generate report, filtering type of instrument that you are going to use. So for example, here we have filtered out valve list, and can you see X position, XYZ position of that particular valve? Such that much detail it is in, and it gives you in Excel sheet. So, and you can save it. Likewise, any other report you can generate, and it can be consumed by your procurement team or a cost estimator, or wherever you want to make use of that. So that is about orthographics manager. uh, its name itself suggests that it manages things, uh, I would say not one at a time, but you can actually prepare how you want, put them in the night, and then morning you see hundreds of drawings has been prepared with a all dimensions and bill of material placed in it, um, and all the equipment dimensions and pipe, their colors, their style is as per your project guidelines. So that is how it helps you. I mean, it takes very less time of engineer. Once you make your project settings, that can be continuously used for that particular project, and if you wish, you can use it in future projects also by making small changes here and there. That's about it from my side. Prem, uh, for Open Plant Orthographics Manager. We will open it for a question and answer. Uh, Prem, can you hear me?
Yeah, Kushal, can you make me present here?
Yes. Mr. Karthikeyan has couple of questions. One in which he asks, can we track the BOM changes between revisions?
Hello,
Yes. Uh,
Kushal,
Prem,
can you hear me?
yes, I can hear you, Prem.
Okay, okay. Can you see my screen?
1 minute. Have you made yourself presenter? Yes, I can see your screen very much.
Okay, so I hope everyone can see my screen over
Yes,
here.
yes.
Just before getting to Q&A, just share one of the few things like as I said, Open Plan can read the or can directly access the brownfield data over here. So right now yeah, we are using one of the point cloud data directly in the Open Plant interface, where the engineers can see the appearance or how the point cloud data was referenced inside the Open Plant. This is a laser scanned with a photogrammetric data,
Hmm.
right? Just by using the camera, personal camera, this data was captured and created a point cloud data, and it has been referenced inside the Open Plant modular. The similar fashion, you can also reference the PDS data over here. And the another interesting about is any existing data can be directly used inside the Open Plant environment just to build an intelligent environment. So here, this is one of the case study where you can see that a big one of the hydrocarbon plant was directly located over here inside the Open Plant interface, right? So now coming to the Q&A session, yes, regarding the question, you can track the bill of material changes. That is yes. Number two question is the system will throw or show some error. Yes, the system will give the report between the mismatch between the PNAD and the 3D model inside the Open Plant environment. Did I answer to your question, Kushal?
Yes. I mean, essentially, you showed that during the demo also, that the PNID process requirement, whether every requirement of the PNID diagram is getting matched with the 3D, it basically turns green once it is being addressed. If it is not, it still shows you red. So that is how it can be tracked.
And you can also
Uh,
get the report out of it.
Correct. One
And
question Mr. Varun asked. You can see the question, Prem, where you use
okay,
this design, where you use this design. Which one? I think is he talking about point cloud data or overall? I don't know. I mean,
so Varun, if you share your number, we can connect to you
correct.
directly, and we can explain you in detail about it. So just a quick one, who are our user, who are do's, as you ask where you use this design. So we have few success stories. Currently what you see is this is you might be heard about Tata Steel plant, which is located in Orissa, right, Kalinga Nagar. This is a number two blast furnace plant, which is developed, designed using Open Plant project wise. Synchro for 4D simulation, and Bentley raceways and cable management, open building designer, and these are the technologies is being used. Bentley technologies to used to create this Tata Steel plant. And the another case scenario is Dusan Heavy Industries, where government of India is awarded this project to Dusan, where the deliverables is to be in Bentley platform dot DGN, which is a microstation platform. And this project is supposed to complete in October 2020. Due to COVID, it was a little bit delay on construction process. And this was one of the power project. And here what you see is 100 mld sewage treatment plant, treatment plant at Jaipur. The municipality corporation awarded this project to SFC Engineering Technologies. They have also used Bentley platform for creating these intelligent data, iModel, as well as the DGN file formats. And what you see is one of the biggest, as of now, the biggest water treatment plant. The unique factor in this is completely all these are presented in the underground. It's a tunnel sewage system where you can see a number of piles where everywhere it was presented. And over the application used was open plant, P&AD, modular, open building, and project wise uh, done by Jacobs, as well as the Singapore National Water Agency. It's a government agency were joined together and done this design. Then there is another case studies for aluminum manufacturing unit. This is in Indonesia region, Bukit. I hope everyone, many of them knows Bukit in Indonesia, right? So this is developed using the open plant, Bentley raceways, as well as the open plant P&AD. So is any other queries is presented? I mean the question and answer. So that's it from my end.
One more question.
Over
Is
to
there
you,
any
Kushal.
student version? Okay. Again, Mr. Varun, we will basically let you know about it. We have got your number, so we'll let you know about that. I think that's it, Prem.
That's it
So
from my end.
yeah. Okay, we are done with even questions also. Thank you everyone for your uh, patient listening to us. And Prem, thank you very much. You delivered really a fantastic, unique technology which basically got added into Open Plant. And I believe plant designers who basically listen to you today will definitely uh, appreciate this. Okay, I mean it's really unique and a latest one, and you will find it damaged the way it works. And hopefully we'll be basically coming up with more such sessions which you will anyway get chance to attend. Thank you very much and have a nice day. Thank you.
Thank
Thank
you,
you,
Bye bye.
sir.
everyone.
Thank you,
Yeah.
sir. Thank you. Yeah, thank you.
Kushal, can I get drop from this?
Uh,
Hello.